Once again, class 9th CBSE. The new lesson of chemistry is the atoms and molecule. It is a part of the unit that is called the particle, nature, their behavior and basic units. Okay. Now topic is the atoms and molecule. In this new syllabus, reduced syllabus, whatever the topic we have to study in this academic session are atoms and molecule, law of chemical proportion, atomic mass, molecular mass, mole concept, and the relation of mole to mass of the particles and the number of the particles. All these topics we have to discuss. Matter. You know very well what is the matter. In Hindi we call it padarth. In Hindi, we call the metal is the padarth. Okay. What is padarth? That is the metal only. And everything is made up of the atom only. Atom. That is called the parmanu. Atom. In Hindi, we call it parmanu. Okay. This is padarth. And this is parmanu. In Hindi, the metal is called padarth. And the atom is called the Parmanu. Parmanu is a term given by Maharishi Kannad around 500 BC. Around 500 BC. Around 500 BC. Maharishi Kannad give this term Parmanu, and further it is given to the all the contribution is in the modern chemistry. We must give all this invention in the name of the Dalton. That is called the atom was first discovered by the Dalton only. But before Dalton in India, this atom is discovered as the name of the Parmanu that is given by Maharishi Kannad. Now what is atom? Something which is very small. Small, it means we are unable to break it in anything simpler. It means it is undivisible. So what is Parmanu according to Maharishi Kannad, or what is atom according to the John Dalton? That atom are something which cannot be split, which cannot be divided in anything simpler, or which is indivisible in nature. Atoms are something or padarth or matter, something or atoms are matter or part of matter, or it is particle which cannot be split or break in anything simpler. It means atom is simplest substance, simplest thing. We are unable to make it anything in the simpler, and that is called indivisible. In short, we are explain what is atom. Atoms are indivisible substance. It is the simplest form which cannot be divided into anything simpler. We have to study about the John Dalton later on. How this atom combine together? That is the big question. When atom combine together, they form the molecule. So what is molecule? Molecule is a simply group of the atom. When two atoms combine, it is called a dimolecule, 3, tri, 4, tetra, and so on. But before that, we have to study about the combination, chemical combination. What are the various type of the combination through which atoms combine together? And that is called the law of chemical combination. This phenomena is given by Anthony Leveseur. This explain all these rules. There are total 5 rules of that we call the law of chemical combination. But in your class, in 9th class, we have to study only about the 2. So there are 2 laws of chemical combination that we have to go through in this lesson. That is given by Anthony Leveseur. He was the person who explained how these atoms combine together. What is the law that is applicable for the combination of all these atoms to form the molecule or to form the compound. So next is the law of chemical combination. What is the law of chemical combination? What are the various ways through which this atom combine together. When atom combine together, they form molecule. When molecule combine together, they form the compound. So what is the rules for the combination of these atoms? This was first proposed by Anthony Levison. For later on, some more chemists do the work on this field, and total 5 laws are composed in this heading that we call the law of chemical combination. Out of which we have to study only 2 in this year, that is in the 9th class. And the first law is law of conservation of mass. This law was proposed by, now here one word is the conservation. Conservation is not a new word for you. You must use this word earlier also as a conservation of forest. Just think, what is the meaning of the conservation? This law was proposed by, Anthony Levison. Actually, he was the chemist who go through for the combination process. So this is he was the person who must propose the first law that we call the law of conservation of mass. As I told you, what is the meaning of the word conservation? Conservation, to protect, to save. Okay, that is the simple meaning of the conservation. And what we are going to save here? We are going to save here the mass of the atom. Every atom has its own mass, and we have to save that mass. That is called the law of conservation of mass. So what is this law states that? This law states that what is this law state that? This law state that during any chemical change, any chemical combination, any chemical process, the total mass of product is equal to the total mass of reactant. It means in any chemical process, mass neither can be created nor destroyed. Okay, that's a simple meaning of the sentence. What is the law of conservation of mass? According to this law, during any chemical change, any chemical process, the total mass of product is always equal to total mass of reactant. So this law states that during any chemical process, the total mass of product, the total mass of product or products is always equal to the total mass of reactant or reactants. Okay, so in other words, we are able to call it that during a chemical process, during a chemical change, during a chemical reaction, mass neither can be created nor destroyed. The mass in both the portion is always the same. So what is the summary of this? That is, mass of reactant is always equal to mass of product. Mass of reactant is always equal to mass of product. So what is the law of conservation of mass? According to the law of conservation of mass, in any chemical process, in any chemical reaction, the total mass of the product is always equal to the total mass of the reactant. Now let's move towards the example. For example, simple, what is the chemical reaction? Chemical reaction consists 2 parts. We put 1 arrow. What we write before arrow is called the reactant. And what all we write after arrow, that is called the products or product, reactant or reactants. Okay, both the thing is there. reactant, maybe more than one, product maybe more than one. So reactants or product. So what is placed before arrow is called the reactant. What is placed after arrow, that is called the product. So for example, we are taking simple carbon combines with oxygen. When carbon combines with oxygen, what happened? The substance which is formed is called the carbon dioxide. Simple chemical composition is there. And what is this law state? That the mass of the substance remain unchanged. Mass of the reactant and mass of the product. Now let's look at, we have to solve some numerical question on the basis of that. Simple numerical. So look at here. The mass of the reactant is equal to mass of the product. Okay. Now what is the mass of the carbon? You have to learn again. The carbon mass is the 12. Oxygen, the mass is the 16. But you have to remember this thing. When you complete these two lessons continuously, that is the atomic structure and atom and molecule, then you very well know what is the masses and from where we get this masses. Till now, we have to know the mass of the carbon is 12. Okay, this is the masses. The mass of the carbon is 12 and the mass of the oxygen is 16. Now let's implement here. Carbon, one carbon is only, mass is 12. Here the mass of O2, 2 oxygen is there, that is 2 into 16. What is the mass here? 12. 16 2s are 32. So what is the total mass here? When we calculate it, it is 44. Okay. Now check out here. Again, here carbon is 12. Oxygen is 2 into 16 and this is 12 plus 32 and again it is equal to 44. Okay, the reactant, whatever the substance is present in the reactant, the mass of the reactant is equal, always equal to the mass of the product. If these two are equal, then we explain that this equation satisfies the law of conservation of mass. This equation satisfies the law of conservation of the mass. So this is the law of conservation of mass. Let's move towards some questions that is based on the law of conservation of mass. Law of conservation of mass. Now you know very well what is the law of conservation of mass, that in any chemical process, any chemical reaction, the mass of the product is always equal to mass of the reactant. Now let's write one question. In a reaction, 5.3 gram of sodium carbonate, 5.3 gram of sodium carbonate were reacted with 6 gram of ethanoic acid solution. Were reacted with 6 gram of ethanoic acid solution. Ethanoic acid solution. The products were 2.2 gram of carbon dioxide, 2.2 gram of carbon dioxide, 0.9 gram of water, 0.9 gram of water, and 8.2 gram of sodium, 8.2 gram of sodium ethanoate, 8.2 gram of sodium ethanoate solution. Show that these observations are in agreement with law of conservation of mass. Show that these observations are in agreement with law of conservation of mass. Law of conservation of mass. Okay, this is one question based on the law of conservation of mass. You have to satisfy, you have to verify that this is based on the same law, that is the law of conservation of mass. You have to put solution for this. Okay, what all you have to do in solution? You have to first form the equation. You have to make the equation. In a reaction, sodium carbonate were reacted with ethanoic acid. Make the reaction. Sodium carbonate reacts with sodium ethanoate. Ethanoic acid. Ethanoate is the product. It is react with ethanoic acid. Ethanoic acid. And what happened as the reaction? We have to put one arrow for the product. What product we get? We get the carbon dioxide, we get the water, and what all we get is the sodium ethanoate. Sodium ethanoate. This is the simple equation and we are able to form it. You are able to write it like this. You know very well, arrow. After the arrow, the substance which is written is the product, and before arrow, whatever the thing is written is the reactant. So all these are the reactant. Here the reactant is more than one, so we have to write here reactants. And all these are the product. Here also the product is more than one, so we call it the products. What all we have to do? We have to justify the law of conservation of mass. For this justification, we have to find out the masses of reactant as well as the mass of the product. Okay, now first we will calculate the mass of reactant. Mass of reactants. Okay, what is the reactant? Sodium carbonate and ethanoic acid. So what we have to do? We have to take the mass of sodium carbonate, or we are able to write like this also. Masses. No, this is not the correct way. We have to write it separately. Okay, the mass of sodium carbonate, mass of sodium carbonate plus mass of ethanoic acid. Ethanoic acid. Okay, now see in the question, whatever the mass is given, 5.3 gram of sodium carbonate. So it is 5.3. Okay, what is the mass were reacted with? 6 gram of ethanoic acid. What is the mass of ethanoic acid? Is 6. Now calculate it. 6 plus 5, 11, and 0.3. This is 11.3 gram. What is the mass of reactant? 11.3 gram. Now we have to find the mass of product. Mass of products. Okay, whatever which is substance which is present in the product, here we have to consider the mass of carbon dioxide, then the mass of water, then the mass of sodium ethanoate. Sodium ethanoate. Okay. Now write the masses. What is given in the question? The product were 2.2 gram of CO2. That is 2.2. Then plus 0.9 gram of water. Okay. Then plus 8.2 gram of sodium ethanoate. Now add all these three. 9, 10, 11, 12, 13, 3. Then remainder is 13, 3. One reminder, 2. and 8, 9, 10, 11.3 gram. It means the mass of reactant is equal to mass of product. So here we write the mass of reactant is equal to mass of product. So, okay, mass of product. So, hence it verifies the law of conservation of mass. I don't think it is little tough. This is the way to solve the question. This is the one question on the basis of the law of conservation of mass. Let's practice one more question. Now one more question on the same topic, that is the law of conservation of mass. Write it down. With the help of law of mass action, with the help of law of mass action, with the help of law of mass action, predict the values of x, y and z in the following. A plus B, this reactant gives C plus B, and whatever given here, that is 1.0 gram, Y, then 1.5. Okay, what is given here? 2.5, 5.0, 3.8. What is given here? 1.5, 3.0, Z, then X, 4.0 and 3.0. Okay, I'm going to solve the confusions. Okay, this is the question that is given, and you have to find out the value of x, y and z. I am not going to find out the value of all these three, x, y, z. I am going to find out the value of only one, that is the x or y or z, whatever thing. They actually have three combinations are given there. This is 1, this is 2 and this is 3. We have to find out the value of x here, we have to find out the value of y here, and we have to find out the value of z here. We have three separate calculations. I am going to the last calculation. This is the first combination, this is second combination, this is third combination. I am going to take the value of z. This is reactant, this is product. So we have to find out the mass of reactant. Okay, I am going to solve this. Okay, value of z. What we have to do? We have to calculate the mass of reactants. That is the mass of reactant. It means the mass of A plus mass of B. Okay, this is mass of A plus B. What we get here? 1.5 and 3.8. So this is 1.5 plus 3.8. Now calculate this. What you get? 0.5, 0.8. 0.8 plus 5 is 30. So here 3.1 reminder. 4 plus 1, 3 plus 1 is 4 plus 1, 5. What we get here? 5.3. What is the mass of reactant? It is 5.3. Now find out the mass of product. The mass of product, Z is missing 1. So how we can calculate the mass of product? Actually, we calculate the Z with the help of mass of reactant minus mass of D. Now what is the mass of reactant? That is 5.3. And what is the mass of D? That is 3.0. Now subtract it. 0 minus 3 minus 0 is 3 and 5 minus 3 is the 2. It is 2.3. Now if you want to check it, just add these two. This is Z. Value of Z is 2.3. To add this 2.3 with 3.0, what you will get is the 5.3. It means your calculation is correct. Now you have to find out the value of X and the value of Y by your own.